For this problem, we're going to A, find the sum of the first n natural numbers. Then for part B, if the sum of the first k natural numbers is 210, we want to find k. Well, we're going to use our solution for part A to help us with part B. And we're going to find the sum of the first n natural numbers in a very similar method to how we found the summation formula and how we found some of the other problems to do with natural numbers. So for part A, we want to write out the sum of the first n natural numbers. So we can do that. We can say we start off with 1, plus 2, plus 3, and so on, all up to plus n minus 2, plus n minus 1, plus n, which is up to our nth natural number there. Well, if we write out all of our terms again, but we reverse the order, such that we have n plus n minus 1 plus n minus 2 plus dot 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 plus 3 plus 2 plus 1. And if we have our expression 1 and expression 2 there, we can add our two expressions. So if we add 1 and 2, we can say that we have 2 times the sum of the first n natural numbers is equal to, well, we have n terms, so we've got n times, and if we group our terms together, each of these terms, when we add them, is n plus 1. n plus 1, n minus 1 plus 2 is n plus 1, n minus 2 plus 3 is n plus 1, and so on. So rearranging that slightly, to get rid of the times 2, if we divide by 2, we have that the sum of the first n natural numbers is equal to n times n plus 1 all over 2. You could expand that, but you don't need to. That is perfectly fine for our expression. So that's the sum of the first n natural numbers, so that's part A. We now need to use this to help us with part B. That says if the sum of the first k natural numbers is 210, find k. Well, our starting point from our expression in part A is that n is going to be equal to k, so that we can say that the sum of the first k natural numbers is equal to k times k plus 1 all over 2. And we know that this is equal to 210. So we need to rearrange and solve this then. So if we expand the brackets, we have k squared plus k. Divided by 2 becomes a times by 2, so that is equal to 420. We're generating a quadratic expression, so we have k squared plus k minus 420 is equal to 0. With this expression, we need to solve this, and we can factorise this expression. So in our two brackets, we have k. K, because it's a minus, our signs are different, one's a plus, one's a minus. Factors of 420 with a difference of 1, well, we have 20 and 21, and it's a plus 1, so we need plus 21 minus 20, and that's equal to 0. So our two k values here are minus 21, and k is equal to 20. Now, both of those can't be valid, and we should know if we're looking for the first k natural numbers, our k value must be positive. So as k must be greater than 0, this implies that k must be equal to 20. And the final thing that we can do is actually just do a little check by substituting this value into our summation of the first k natural numbers, show it's equal to 210. You would have 20 times 20 plus 1, which is 21, all over 2. 20 times 21 is 420, divided by 2 is 210, so that must be correct, because that's what we were told in the question. So our k value must indeed be equal to 20. And that's how we solve this problem.